Okay, welcome year 9. I have been amazed by the work you've uploaded to your class charts in such a short amount of time. Got into school this morning just for a quick little trip, just to get myself sorted for the next few weeks. And you'd already had work put up. So many of you. And every time I'm checking class charts, there's more and more and more and more stuff. I'm so pleased. So there's a picture of me. That's supposed to be a hand with a thumb up. I'm still working on my hands, but there we go. So I just thought I'd just show off some of the fantastic stuff that you've done. So we've got first piece of work already uploaded. So we've got all the different energy types. We've got the equations. We've got slightly more messy, but still got everything we need. We've got all the equations. We've got the calculation. We've got a nice Sankey diagram. Beautifully neat piece of work here. Again, we've got all the energy types. We've got the equation. We've got Sankey diagram. We've got the little calculation. Again here, beautiful Sankey diagram with different numbers to mine. It was perfect. We've got all the different types of equations you could have. So you could have the word equation or the symbol equation, and then written without the actual operators, multiplication sign. Fantastic bit of work. Self-marking, loved that without being prompted. Really good. And then we've got a description of conduction and convection. We've got another really nice piece of work. You've got to be careful of these Sankey diagrams here, because the input energy, that thickness there, should be the same as the total thickness of the light and the heat, whereas the heat just seems to sort of come out the side. So your numbers are good. The numbers are good, but just want to be careful of that thickness of the Sankey diagram there. Apart from that, really good. Beautiful piece of work here. You've got to be careful in your description of convection. Conduction is lovely, but you've got to be careful in your description of convection, because using the word vibrates a little bit too much when talking about convection. You really want to talk about the fact that the particles are moving more vigorously. They're moving faster. Therefore, they're taking up more space. It's not that they're vibrating more. They've got more kinetic energy. They're moving quicker, so they're taking up more space, so that density changes. Okay, it's not that they're vibrating really in a liquid and a gas in this context. Okay, but apart from that, it's a beautiful piece of work. Love the colour. Love your diagram here. Much better than the diagram that I did in my video, because you can see the particles are beautifully touching all throughout that metal rod. Another lovely piece of work here. We've got the equations. We've got a lovely Sankey diagram. You can have the wasted energy going up, but normally you would put it down in the diagram, just as long as it's not going along in that same direction. Beautiful. Love a spider diagram. Love a spider diagram. Brilliant. We've got some really good information here. Another nice piece of work here. We've got the equations. We've got a nice calculation. This is a much better example of a Sankey diagram. So you can see how this is 2 lines thick and this is 1 line thick. Okay, because it's 3 lines thick going in. So instead of here, where it's 2.5 lines thick, 2.5 lines thick, and then an extra bit of line. Okay, so this is a lovely Sankey diagram here. Very good. Beautiful piece of work here. Little descriptions, little paragraphs of conduction and convection. Nice calculation. We've got clear workings out here. We've got all the types of energy. Careful of this Sankey diagram again, because we've got that little bit of heat energy coming out, but it's not represented in those arrows. So you've got your numbers right, but just be careful of the drawing. Lovely piece of work here. So we've got the equations. We've got the different types of energies written out with those letters at the beginning. You can see all those students who remember that acronym, okay, are getting them all. But what have we forgotten at the top? Got to remember them most for magnetic. Okay, so moving from NXL to AQA, we need to know that magnetic can have some kind of potential energy depending on the situation. Okay, this is another piece of work. Got to be careful of your Sankey diagram. Remember, we want to have that extra bit up the top to show that it's not going forward. Okay, because your numbers are right, but the thickness going in has to equal the total thickness coming out, because the energy going in has to equal the total energy coming out. Conservation of energy, really important. Beautiful diagram here. Make them touch. Make them touch. Better than my diagram. Got to make it better than mine. Okay, but nice piece of work. Lovely piece of work here. Nice Sankey diagram again, because we've got this this thickness is the right size. So you've got the thickness of the useful and the wasted gives you the total thickness going in. Nice calculation, got the energy types and the equations. And we've got a nice little description of these two. When we're talking about conduction, you do talk about conduction of electricity, but when we're thinking it in this context, when we're looking at energy, we're looking at the transfer of heat. So it's not just the conduction of electricity. Okay, we really want to focus on the conduction of heat. So how that vibration is passed along from one particle to the next. Okay, but still, this convection answer is very good. We've got a lovely little Word document, maybe. I'm not sure what this is in. I'm assuming that just because it's fiddly, it's difficult to get the two to go into a squared. Oh, I think that's my BBC bite-sized diagram. Very good. And we've got this. I love this part. So we've got a nice little starter with self-marking, which is really good to do. Really good. We've got a nice little table comparison here. A little checklist with nice pretty titles. It's nice. But I do really like the idea that we're going to summarise it after 2 weeks. So in a couple of weeks' time, we're going to put some information down here. Really, really nice to see. Spider diagrams, fantastic, as I love a spider diagram. We've got some information here, very good. And for conduction, I like the diagram here showing those particles moving along, very good. We've got, this must be a Word document, where we've got all the different energy types. Careful of your spelling of elastic. We've got all the units, we've got the equations, very good. Beautiful diagrams here. Careful of your Sankey diagram. You've got the right idea, but just careful of that thickness. Remember, we want that thickness consistent. Good equations. We've got nice showing the vibrations moving along. You might want to try and draw your particles a little bit more ordered, but it's still very good. We've got some information here. Nice little diagram showing convection currents. Lovely Sankey diagram here. Good calculation. Maybe putting a little bit more workings would be nice to see. Very good. And we have had a couple of submissions on Word that I can see. So we've got this beautiful picture. We've got all the different energy types. We've got a little Sankey diagram drawn with the arrows. It's difficult in Word to actually make the thickness of the same, so I can forgive you that. You've got the numbers right. And again, with the 2, you want to get that superscript, not subscript, because it'll be a square. I like your little diagrams here with the little informations. I'm not sure why you've got your candle next to conduction, but your actual text, the actual understanding of the text is good. This next one is one of my favourites. It's brilliant, where we've got, I think it just cropped the picture of the video, and we've got the information, we've got the answers here, and you're ticking them, and you're not just ticking. So lots of you have done the marking, but you're also then correcting, which is brilliant to see. Brilliant to see. So if you didn't know what 4 was, that's the time when you go away, spend a little bit extra time, go BBC Bite Size, look at power, start doing some practice on that. Okay, but a lovely, lovely piece of work, The only thing that I'd be looking at is this section here. Okay, because it's right in your head, I think, but you're not explaining it in a way that you can get the marks, because you've made a mistake that lots and lots and lots of students will do. So you've said the particles heat up, perfect. Because they heat up, they become less dense. The way you phrase this, it's going to make the examiner think that the particle itself changes density. The particle will change size. It will become less or more dense. It's not the particle on its own that becomes less dense, it's the group. So when you say the particles heat up, that's brilliant. But you need to then go on to say, if the particles have more energy, they're moving faster. If they're moving faster, then the fluid becomes less dense. The air becomes less dense. The water, the oil, whatever it is, becomes less dense. It's not the particles. So be careful with that explanation here. Apart from that, it's a fantastic piece of work. And the last one here, just for special mention, because we've got the energy types. Okay, we've got a nice little Sankey diagram here. We've got our equation. Okay, we've got another little Sankey diagram here, and what I think must be maybe a picture of me with my beard. Maybe, I'm not sure, but it's very good. So listen, Year 9, I was so pleased to look at the work that's being uploaded, and I've not included anywhere near everybody's work. Okay, it's still coming in, so keep submitting it. I'll try and write little pieces of feedback on class charts for you. honestly, like I say it again, so super stoked to see how much work you're putting in completely independently. It's absolutely fantastic. Very well done. Take care, everybody. Bye bye.